Just want to look at parallel lines. And I want you to think about the gradients of lines that are parallel. Now, if I had two lines that are parallel, say that one, that went through 2 minus 2, and then I draw a second line, let's go through 4 minus 4. I'm going to draw that because I want it to be exactly parallel to the other line. So if you take a good look at that and you look at the rise and the run on this one, and then you go and you look at the rise and the run on this one, if the lines are parallel, so the rise here is 2, the rise is 2 and 2 on the first one, so the gradient is 2 on 2, which is 1. And when you look at the second one here, that's 4 on 4. So the gradient is 4 on 4, which is 1. So what you notice is that they have the same gradient. Both gradients are equal to 1. And that makes sense because if two things are going to slope in the same way or in the same direction, then they need to be parallel. Like if you think of the train tracks slope in the same way, like the two tracks on the train, therefore they must be parallel, as long as they're going in the same direction. So where that takes us, if I look at like y equals mx plus b in any equation, we know that the number in front of the x, we know that that represents the gradient. That one there is the gradient. So if I would like to show that two lines are parallel, the number in front of the x must be exactly the same. So if I look at these two here, if we look at their gradients, I've got a 2 there, and I have a minus 3. Their y-intercepts are the same, but their gradients are not the same. So therefore, the gradients are not the same. In line 1, the gradient is equal to 2, and line 2, the gradient is a minus 3. Not the same, therefore they are not parallel. If we look at, say, y equals 3x minus 4 and y equals 3x plus 2, these ones have two different y-intercepts. But if you look at their gradients, the gradient's the number in front of the x, they will actually have the same gradient. And because they have the same gradient, then the two lines will slope the same, and the two lines are parallel because the gradient of the first one is 3 and the gradient of the second one is 3. So same gradient, therefore they must be sloping the same way, therefore they are parallel. So if I give you a few lines, we're just going to highlight the ones that we think are parallel. So we've got y equals 4x plus 3, y equals 2x plus 3, y equals minus 4x plus 1, y equals 4x minus 3, y equals minus 2x plus 1, y equals 4x plus 5. So when you're looking to see which ones you think are parallel, they have to have the number in front of the x has to be the same. Now I can actually see 3 things, and I'm going to highlight that now in green, where the number in front of the x is equal to a 4. Therefore, when you're looking at gradients here, the first one has a gradient of 4 I don't care about the y-intercept because I'm worried if they're parallel. Second one's 2. Third one's minus 4. Fourth one, the gradient is 4. Fifth one, the gradient is minus 2. And the sixth one, the gradient is 4. So that means when we're looking at ones that are that have exactly the same gradient, it would be the fourth and the sixth one, and that one, there's another one, that is the fourth one, and the sixth one. These lines will all be parallel. They'll all be parallel because they all have the same gradient value.